Okay, in this problem set, we're going to reinforce what you learned so far. We're going to spend a lot of time talking about negative exponents, and then we're going to introduce one more rule. But this is where we're at so far. You have the basic definition of exponents. Remember, it says that when you have a base to an exponent, to a power, that the exponent tells you how many times the base is multiplying itself, right? And then if you have a base to the first power, it's just itself. That's what that says. And don't get that confused with a base to the zero power, because a base to the zero power is 1. And then, like I mentioned before, I think this is the most useful rule that says if you have a base to a power and then the same base to another power, and you're multiplying them, you keep the base the same and add the powers together. It only works when you're multiplying. If you were adding these two together, they'd have to be like terms in order to add. And that means that not only would the bases have to be the same, but the exponents would have to be the same as well. Okay, and then last time we talked about this, the idea of negative exponents. When you have a negative exponent on the top, you can move it down to the bottom, make it positive. When you have a negative exponent on the bottom, you can move it to the top and make it positive. So you can think of them together as saying cross the line, change the sign. That means whenever you move an exponent across the division line, you change the sign of the exponent. One thing that's really important to notice, this is what we're going to focus on first, is you can use Rule 4 with negative exponents. Rule 4 says as long as the bases are the same and you're multiplying, you can add the exponents. Okay, so on this first example here, I guess the instructions would be to simplify. You can use Rule 4 because you're multiplying and the bases are the same. So if you add the exponents, what do you get? You get y to the negative 2 power. Now y to the negative 2 power, you can move down the exponent. You would not leave your answer like this. It's not considered simplify. Move it down to the bottom, make it a positive 2. So 1 over y to the 2 is your answer. So look at number B then. When you multiply these two together, you can use Rule 4. You can multiply the coefficients together. Negative 2 times 5 is negative 10. But what is x to the negative 4 times x to the negative 3? Since the bases are the same, you can add the exponents. So you get negative 10 times x to the negative 4 plus negative 3, which is negative 7. You wouldn't leave your answer like that, though. You'd move it down to the denominator. Final answer would be negative 10 over x to the 7th power. So, like I was saying, you can use Rule 4 when you have negative exponents as well. Alright, well, let's see if you got that. Try these two. See if you can do these two problems. Give you a couple of minutes. Go ahead and hit the pause button. Now on the first one, you should have multiplied negative 7 times 2, got negative 14, and then added the exponents. X to the negative 4 plus 2 becomes x to the negative 2 power. And then you would move down. Notice the x moves down, the negative 14 doesn't because it's not part of the base. So you get negative 14 over x squared. And on D, it looks really complicated, but you can actually look at each of these separately. You can multiply the coefficients. Negative 2 times 3 is negative 6, right? And when you add the exponents, x to the negative 3 plus 2 is x to the negative 1. And what do you get here? Y to the 4 plus negative 4, you get y to the 0. You can do all that because everything's being multiplied, remember? That's what the rule says. And you certainly wouldn't leave your answer like that. Y to the 0 is just 1, so we just drop it. And you move the x down, x to the negative 1 down to the bottom, make it a positive exponent. Notice the negative 6 stays on top. Alright, let's keep on going. There's one more rule we're going to introduce here. This rule should make a little bit of sense, I think. Remember when you multiply two things with the same base, you add the exponents? Well, this says when you divide two expressions with the same base, you subtract the exponents. When you divide, you subtract the exponents. When you multiply, you add. So it seems kind of reasonable. So if you had something like z to the 8th over z to the 5th, this new rule says you would take this expression and write as z to the 8 minus 5 power, which is z to the 3rd power. That's your answer. Or how about this one? When you have x, this is where you have to be a little careful here. Look, when you have x to the negative 4 over x to the negative 6, you take it and write it as x to the negative 4 minus negative 6. You see how you have to take the top exponent minus the bottom one? So you got to be careful with your negative signs. What does that become? It becomes x to the negative 4 plus 6, which is x to the 2 power. Kind of tricky. By the way, some of you maybe realize this. There's another way to look at this also. Instead of looking at it that way, remember what you can do to that x to the negative 6 power? Couldn't you move that x to the negative 6 up to the top and make it a x to the positive 6? That's what we learned last time. So this x to the negative 6 can be moved up to the top. You could make it times x to the positive 6. And then you could use rule 4 where you just add the exponents. So there's different ways of getting the same thing. And that's what's so great about this this topic of rules of exponents. Oftentimes there's more than one way to do things. Anyway, let's keep on going. Some of these get more involved, but if you know what to do, they're not that hard, are they? Look at this one. Here what you can do, using this new rule we just talked about, rule 6, is you could, you have x to the 4th, y to the negative 1 over x to the negative 2, y to the 2. You could treat each of these separately. You could subtract the exponent, since everything's being multiplied and divided, you could subtract the exponents on the x, and get x to the 4 minus negative 2. Be careful with your minus signs. And here you could subtract the exponents on the y, and write as y to the negative 1 minus 2. So you get x to the 6, right, times y to the negative 3. You wouldn't leave your answer like that. You would move your y to the negative 3 down to the bottom. So your answer would be x to the 6 over y to the 3. Now this one, again, this is similar to what we were looking at before. It looks complicated, but since everything's being multiplied, you could just look at each of these factors separately. Negative 2 times 6 is negative 12, right? M to the what? M to the 0, right? And n, remember, this is n to the 1. What's n to the 1 times n to the negative 4? It would be n to the negative 3. How would you write your final answer? Well, m to the 0 is just 1, so you can just drop it. You leave it as negative 12 over n to the 3rd. Alright, well, let's see. Got a little bit of time left. Why don't you hit the pause button and see if you can try these last two. We'll go over these in just a second. Now, these last two don't involve negative exponents at all. Did you notice that? In fact, this first one, you're adding. And in order to add these two together, they better be like terms, which means they have to have the same variables to the same powers. Do these two terms have the same variables to the same powers? Yes, they do. So you can add, this is one of those cases where you could actually add these. What do you get when you add negative 3s to the 4th plus 8s to the 4th? You add the coefficients and get 5. You do not change the exponent. You keep the exponent the same, so it becomes 5s to the 4th. Don't get that confused with this one. This last one, you multiply the coefficients to get negative 24. Now when you multiply with the same base, what do? You keep the base the same and add the exponents. So don't get confused on these guys right here. Alrighty, I guess that's it for now. We'll see you next time. Bye-bye.